In estuaries off the coast of Georgia, the water is so murky that if you were to dive in, you couldn't see your hand in front of your face. There, blue crabs feast on mud crabs, oysters, fish, and more. You may eagerly approach these hand-sized arthropods when they're cracked into pieces and doused in butter. But in muddy water, tiny mud crabs, no bigger than the tip of your thumb, steer clear of the hungry blue crab predators. In this crab-eat-crab world, they can't see their enemies coming, but they can smell them. Chemicals in blue crab urine are scented death messages to mud crabs. The language is different, but the warning is clear: hide, or be eaten. Blue crabs probably don't want to send out the message, but they can't help it. "We all have to pee," said Julia Kubanek, a marine chemical ecologist at Georgia Institute of Technology. Of more than 600 chemicals that make up blue crab urine, only 2 signal danger for mud crabs, Dr. Kubanek and her colleagues found in a study published Monday in Proceedings of the National Academy of Sciences. These chemicals, produced when blue crabs break down dinner, tell the mud crab what was served. They're especially powerful if the last meal was mud crab. They smell death around them, and if that death is of their own type, they want out of there, said Dr. Kubanek. This invisible, underwater messaging system has far-reaching signals. Just a single blue crab eating one mud crab and then urinating in an estuary can change the interactions up and down the food chain in that marine ecosystem. What researchers find about chemical cues or pollutants may help conservationists better manage crab and oyster fisheries in the future. Researchers had already identified the smell go hide warning system in these crabs. When scientists extracted urine from blue crabs and injected it into a tank of mud crabs, it was clear that something about it induced fear in mud crabs. But what? Dr. Kubanek and her colleagues fed blue crabs different diets that would break down into urine samples, each with their own threat level and a distinct chemical profile. To get a sense of a sample's threat power, the researchers hid shrimp in a tank of mud crabs and measured which urine samples prompted the mud crabs to eat less and hide more. The researchers looked for chemical features that varied in the samples that induced the biggest fear responses. This relatively new technique for comparing chemical profiles, called metabolomics, revealed 2 important chemical signals: trigonelline and homarine. These molecules are common products of animal metabolism and are also found in some plants. Trigonelline in coffee beans contributes to their aroma when roasted. It's not clear if humans can actually smell the substance by itself. But mud crabs do. It's just not clear how. They're kind of walking noses, as Mark Weisberg, a biologist at Georgia Tech and co-author on the paper, puts it. Mud crabs likely detect the chemicals with sensory organs on antennas, mouth parts, or legs. The ecological communities of places like a Georgia estuary or an oyster reef are critically structured by predator-prey interactions, and it turns out those predator-prey interactions are very much affected by chemical cues, said Dr. Kubanek. "I think it's pretty cool that the chemistry of pee matters.